One very nice way that I might be able to introduce some additional checking in my Python code is by using PEP44 type hinting tools like MyPy or Pyre. Let me show you an example of MyPy. Here, with MyPy, I'm going to model the inputs and the outputs of this function as strings. And I'm going to use the typing module to indicate that the string representing the shape can be a literal value of rock, paper, or scissors, but nothing else. The literal value representing the result can be a win, a loss, or a tie, but nothing else. And the rest of this code doesn't change. However, if I run this code through MyPy, I can actually check to make sure that all of the inputs and the outputs are as we expect. And so, for example, if I run MyPy without making any further change to this code, I get a bunch of errors. Because MyPy says, you know what, you assigned the result of a random choice between 3 strings to player, but I'm not going to try and figure out if those 3 strings overlap with the literal value rock, paper, scissors. I'm going to force you to do a little bit of work to make sure that, for example, if this changes here, then this check also has to change. So what I'll do is I'll get my arguments for my literal value. There we go. And you can see the number of errors that I have has reduced. If I do the same thing for the challenger, then I have far fewer errors. MyPy says, you know, there's always a possibility, whatever the case may be, that we could fall off the end of this function. It's not going to be able to identify that we've exhaustively checked all the possibilities of the player and the challenger inputs. And so it's saying, you know what, since I can't quite analyze that this is an exhaustive combination of every player or challenger shape, you're going to fall off the end, and I want you to be more explicit about that. However, if I make this return none here, then I have to update this result here. And so there are some downsides to this particular modeling. I think this error here you might consider to be spurious, and we might need to mask that out. We might say, you know what, I checked this. There's no way that there could be a mistake here. Similarly, this doesn't really prevent us from making mistakes at this level here. Note that this now says lose when it really should be loss. And MyPy wasn't able to detect that this is a mistake. I could try to extract this into its own variable and say if the result equals win, if the result equals tie, or if the result equals lose or loss. And I could even be very specific and say this has the type result at literal value, but still it doesn't check this if-else case because, of course, Python says, you know what, you can still compare this to something else, some other string value. And I don't necessarily know the logic of what that comparison might actually do. You can, of course, overwrite _e cube to your heart's content. And as a consequence, I've lost that ability to check this one little detail. Now, there are some improvements that I can have even to my use of MyPy here. I can make use of getArgs. I can extract this here. But for the most part, I'm going to hit a brick wall without some additional sophistication. And one thing that you'll notice is that MyPy is a very good tool when used in moderation, but there are some cases where it really requires an unnecessary amount of sophistication to catch some very small errors. The case of mistaking lose for loss might be something that we definitely do want to catch, but the case of, you know, returning something if this is not exhaustive, maybe we don't care that much. Maybe that's just something we want to say, you know what, I'm pretty sure this code is checked. Checked it 15 times already. I have some unit tests. MyPy, that's not a helpful thing for you to flag for me. And so instead, we might reach for another part of the Python standard library. Instead of using a typing.literal, we'll represent the shapes and the results as an enumerated value. And one of the upsides of using an enumerated value here is we can first replace all of the double equals checks with is checks. The enumerated values are singleton values. And second, any code that exists at the top level of our program that tries to access a value from this enumeration will error out if it accesses a non-existent value from the enumeration. So if I say result.lose here, well, the moment that I get to this branch here, I'll see that I'll get an error. So the error won't be completely checkable up front, but at least I'll see an error message here that says, hold on a second, you have done something wrong. And if I combine the use of this enum.enum with MyPy, well, MyPy can check for me statically, oh, type result has no attribute lose. That's exactly what I was looking for. And so perhaps the improvement here is not just the use of MyPy together with a typing.literal, but the use of MyPy plus a better structuring available to us in the Python standard library through the enum.enum. You can imagine that if we put this code in a tight loop, it's the case that the isCheck will be faster than double equals check. That's just going to be checking that the two Py object pointers point to the same thing. And it's the case that in some places we may even want to make use of that enumerator value. You might want to add some additional detail to that enumerator value. For example, note that we're printing the name out and then lowercasing it. Maybe we want to add another field here, which is like the pretty printable name. So we'll extend this enum type with the pretty printable name that's used for any one of our reports that we have on the results of this rock, paper, scissors simulation. Now, having improved the code so far, one improvement that still needs to be made is to make this code a lot less noisy. Note how noisy it is with all of these if-else. And here I've actually even reduced the number of if-else by taking all the possible ties and making that one branch. I could even make this the default behavior if I haven't met one of these conditions, rock versus paper, rock, scissors, paper, rock, paper, scissors, scissors, rock, scissors, paper, then it's necessarily a tie, or I could check more explicitly if the player and the challenger have the same shape, it's a tie. This is a little bit less noisy, but it's still very noisy because when you look at this, can you really eyeball and make sure that we haven't made a mistake, that we haven't left something out, that we haven't checked something twice? I don't think so. And so what we might need to find is more structure in this if-else logic. I could make use of a recent addition to the Python grammar, the use of the match case statement, to make this logic a little bit more visible. I could switch this back to taking care of all of the 9 possibilities of shapes and counter shapes that can be thrown. And here you can see, okay, that's the rock, that's the paper, that's the scissors with rock, paper, scissors, rock, paper, scissors, rock, paper, scissors. Okay, I can quickly, easily at least eyeball this and make sure that's exhaustive. You always tie once, win once, and lose once. And I guess one error that could be remaining from this is I could accidentally swap a tie and a win or a win and a loss. But for the most part, you can see that just visually, the use of this match case has a slight improvement over the original and that I can eyeball it more effectively. Now, of course, I could have done some things like this. I could have put this onto one line here and I could have spaced this out to make it a little bit easier to eyeball. And so that improvement is, I would say, fairly minor. In fact, I would argue that the use of the match case statement in Python is really beneficial when you want to extract something from the underlying objects, not just when you want to match some particular pattern here. And so just matching for rock and rock seems to be perhaps a more gratuitous use of this match case. If you like this syntax, you may like the way that this looks, and of course that is a valid opinion. But for the most part, I think unless we're going to try and pull some data out of these objects really have no additional payload, then there's really not that much that's gained here over the if-else. Instead, I might lean towards something that we traditionally used to model switch case or match case type statements in Python. That is, prior to the introduction of match case, when we wanted something that was similar to what you have in JavaScript or in shell scripting or in C and C++, a switch case statement, you'd instead use a dictionary. And so here I'm going to model each one of these possibilities as a dictionary of each one of the player and challenger tuples and the result. And you can see that it's as visually noisy or as free of visual noise as the match case. And for the most part, this mostly works. I mean, it return a none value if you fall off the end, if the case you're looking for isn't present. And we might even be able to introduce a couple of additional checks here. We could say that these are the rules of the game, and we could put this up at our module scope. And right after defining this, we could programmatically check it. We could programmatically check it by inserting that the win, loss, and tie appear only once. So for example, we could do something like something here. We could assert that for our rules, let's go through these. These are the keys. For the keys in the rules, let's take the player shape and then the challenger shape from these. Let's take the player shape here. And there we have the result. And let's do this. And let's actually do it like this. We'll do a tuple here with the result, .items. And Here, we should anticipate seeing for each player shape, there should be one unique result. And so we should see that the length of this thing should be equal to the total number of player shapes times 3. And this ensures that we don't accidentally double something. Of course, we can eyeball this just as effectively, but here we can actually have some kind of programmatic checking. And we can do all sorts of additional programmatic checking now that we're representing this in some data-driven approach.